Welcome back. We are doing 7th grade math, chapter 4, lesson 5. We are adding and subtracting mixed numbers today. Now, our first thing we need to talk about is, what is a mixed number? A mixed number is any fraction that is also accompanied by a whole number. This is a mixed number. You have your fraction component and you have a whole number attached to that fraction. This is a mixed number. Today we're going to be talking about adding and subtracting mixed numbers. So let's say I have 3 1/2 plus 2 1/3. The thing that I need to keep in mind is I cannot add fractions that are not like fractions, aka they don't have common denominators. So when I'm doing this, what I'm going to want to do is I want to isolate the fractions first, add or subtract them, whatever is happening. In this case, we are adding them. And then we'll add these two first, and then we'll add the whole numbers later, just in case we get an improper fraction, we get a whole that needs to go over. In this case, I'd have 1/2 plus 1/3. Cannot add these together the way that they are. I'm going to multiply this by 3 and multiply this by 2 because I want a common denominator. And I know if I count by 2s and 3s, the first number that both of them is going to hit is 6. So when I multiply these, this will become 2/6, and this will become 3/6. When I add these together, I'm going to do numerator plus numerator, which will give me 5, and the denominators will stay the same. So I have 5/6, and 5/6 is simplified. Now I'm going to focus on the whole numbers. 3 plus 2 will also give me 5, therefore I will have 5 and 5/6. Now, there's a more convoluted way to do this, which I know you're already going to say, Mr. Pastor, isn't this going to be more work? Technically it is, but sometimes this is actually the easier way to do this. So let me go ahead and show you what is the other way to do this. The other way to do this is to make these both improper fractions and then add that together and simplify. In order to do that, I would take my whole number, multiply it by denominator, add it to numerator, and put it all over the original denominator. So 3 times 2 would be 6, plus 1 is 7. So this would become 7 over 2. And I would add it to 2 times 3 is 6, plus 1 is 7, and I would put it over 3. Same rules apply here. I cannot add these two together because I don't have a common denominator. I'm going to make a common denominator by multiplying these two by 2 and these two by 3, which will make this 21 over 6 plus 14 over 6. Now, when I add these two together, I'm going to get 35 over 6. Totally improper number. Or improper fraction, I should say. I'm going to simplify this down, and watch. I'm going to get 5 and 5/6. 35 divided by 6. 6 goes into 35 5 times. That will equal 30. When I subtract, I'll have 5 left over. My answer is 5 and 5/6, which is exactly what I had to begin with. But that was a little bit more work. Now, there are times where this is going to come in handy, like if you're subtracting fractions from other fractions that are bigger, and then you'd have to borrow from the whole number, and if you can't wrap your brain around that, like I kind of can't, it's just easier if we do improper fractions to deal with it. So that's your second way of doing it. Now let's go ahead and review our notes here, and then we're going to get into some examples. Adding and subtracting mixed numbers. A mixed number is where there is a whole number and a fraction, like we talked about. Example here is 3 1/4. An example of a mixed number being subtracted here is 4 5/6 minus 3 2/3. I can't subtract 5/6 and 2/3 because they don't have a common denominator. So right here it's illustrated that the 2/3 is going to become 4/6. Because I can change that 3 to become 6 easily by multiplying it by 2. When that happens, I'm looking at the fractions first here. 5/6 minus 4/6 will give me 1/6, as illustrated right here. And 4 minus 3 will give me 1. So this will be 1 1/6, and because it is already simplified, we are done. So again, recapping, you're going to subtract the fractions first, or add the fractions first. You are going to then do the whole numbers and make sure you simplify. So let's look at an example here. We have 7 and 4/9 plus 10, 7 and 4/9 plus 10 and 2/9, if I read that correctly. It is 10 and 2/9. Now, our denominators are the same, so we're lucky there. We don't have to do any prep work. We are going to just take these two fractions and add them together. 4 plus 2 will be 6. It'll be 6/9, and I'm telling you right now, not simplified. We can do that later. Then I'll add my 7 plus 10, which will become 17. My answer here is 17 and 6/9, but that 6 and 9 both have common factors of 3, which will then make this 17 and 3. 6 divided by 3 is 2, and 9 divided by 3 is 3. So my answer will become 17 and 2/3. Let's erase what's on screen, and let's get to the next problem. We've got 8 and 5/6. 8 and 5/6 minus 2 and 1/3. Again, we focus on the fractions first, and we do not have common denominators. We got a 3 and a 6. I cannot subtract these. Now, I could try to make the 6 to 3, but I can't divide 5 by 2. So on the flip side over here, I'm going to multiply these both by 2. This will give me 2/6. Now, I have 5/6 minus 2/6, because again, this is a subtraction problem, which will give me 3/6. And I'm telling you right now, not simplified. 3 and 6 both have 3 in common. This will become 1/2. Now I can subtract the whole numbers. 8 minus 2 will give me 6. So my answer here is 6 and 1/2. It is simplified. I did the fractions first. I did the whole numbers second. I made sure it was simplified, and we are good to go. Now, let's get some examples under our belt so that we know that we can do this. And here's a group of 6 examples that we're going to be doing here, somewhat rapid fire. Now, A, totally doable. We have common denominators. They are like fractions. Over here, not happening. Here, not happening. Here, not happening. Here, not happening. And here, not happening. So this is the only one that's set up easy for us. 6 and 1/8 plus 2 and 5/8. I'm just going to add that 1 and that 5 together, which will give me 6/8. 6 plus 2 is 8. So my answer here will be 8 and 6/8. But that 6 and 8 are not simplified. So again, let me recap. 6 and 1/8 plus 2 and 5/8. So again, the 8s are common. They come over. 1 plus 5 will give me 6, and 6 plus 2 will give me 8. That's how I got 8 and 6/8. The 6/8 both can be divided by 2, which will then give me 8 and 3/4 is my answer. Simplified. Now, the rest of these examples, not as easy, because we're going to have some converting to do. We got 5 and 1/5. 5 and 1/5. And we are adding 2 and 3. Wow. 2 and 3/10. I need to focus on the fractions first. This is 1/5 and 3/10. Not happening. However, I'm going to turn that 5 into a 10 by multiplying these both by 2. This will make 1/5 into 2/10. I can add the 2 and the 3 together. This will give me 5/10. Both of these have a common factor of 5. This 5/10 will become 1/2. So, simplified it already ahead of time. I added my two fractions, 2/10 and 3/10. Now all I need to do is add my whole numbers. 5 plus 2 is 7. So my answer should be 7 1/2. And that's it. All right, let's do the other examples here. We've got 1 5/9. 1 5/9 plus 4 1/6. Now, the 6 and the 9 both have a common factor of 3. If I could divide them both down to 3, cool, but I can't because there's a 1 here that won't divide, and if I divide this by 3, that won't divide. So, therefore, we're going to need to find the lowest common multiple between 9 and 6. So, again, I could just multiply both sides by the opposite, or I can start counting by each thing. Got 6. Oh, not 9. I'm counting by 3s. 6, 12, and 18. And guess what? In 9, we have 9 and then 18. 18 will be the least common denominator between these two. Therefore, I need to know what to multiply to get each of them to become 18. On the 9 side, I'm going to multiply both of these by 2. On the 6 side, both by 3. I'm going to go ahead and rewrite my equation down here. When I am done, this will still become 1, and 2 times 5 will become 10, and 9 times 2 will be 18. So I've got 1 and 10/18, and I'm adding 4, and 1 times 3 will be 3, and 6 times 3 will be 18. And I will have 1 and 10/18 plus 4 and 3/18. I can bring the 18 over already. 10 plus 3 will be 13. And I can tell you right now, 13/18 is simplified. They will have nothing in common because 13 is a prime number, which only has 1 and itself as a factor. And since 18 is not a multiple of 13, it's done. It's simplified. Then I will add 1 plus 4, and it will become 5 and 13/18. And there is my answer. Now we're going to get into some subtraction problems. I got 5 4/5. 5 4/5 minus 1 3/10. So I cannot subtract at all because we do not have like fractions. I can't convert this down to become 5 because 3 divided by 2 will not happen. I'm going to up convert this 4/5 to become 10. So I'm going to multiply them both by 2. Rewriting my equation, 4 times 2 will be 8. 5 times 2 will be 10. Minus 1 3/10. Now, we're going to focus on the fractions first. Now that the fractions are done, 8 minus 3 will be 5. This will become 5/10, or, not simplified, 5 out of 10, same thing as saying 1/2. If I divided 5 by 5 and 10 by 5, it would give me 1/2. Now I'm going to subtract 1 from 5. 5 minus 1 gives me 4. My answer is 4 1/2. And I haven't had to change any numbers into improper fractions to do this so far. So, pretty simple stuff. Let's get these last two examples under our belt, and then we will call this one a lesson for today. 13 7/8. 13 7/8 minus 9 3/4. Now, I can't convert that 7/8 to have a denominator of 4 because I'd have to divide both by 2, and that 7's not going to work. So I'm going to go ahead and multiply these both by 2 so that we can turn it into 8. When I multiply 4 by 2, it becomes 8, and 3 by 2 will become 6. I have common denominators. Now I'm going to subtract these two because it says it's subtraction. 7 minus 6 is 1. The 8s stay the same. And then 13 minus 9. And I'm going to do mental math. I have 13, 3 over 10, so there's 3 gone. I still have to subtract 6 more, so that'll be 4. 4 1/8. Another way to do that is just add, go from 9 and add 1 until you get to 13. 9, 10, 11, 12, 13. So that gave us 4 ones. So my correct answer here is 4 1/8, because that 1/8 is simplified because the numerator is 1. Anytime the numerator is 1, your fraction is simplified. All right. That was D today. Now let's do, no, that was E. We did E. We have one last one left. 8 2/3. 8 2/3 minus 2 1/2. Did I write that correctly? I did. So back to our 3 and 2s. We know that these are both going to need to become 6s. So I'm going to multiply this by 3 and this by 2. This will become 8, and 2 times 2 is 4. 3 times 2 is 6, minus 2, and 1 times 3 is 3. 2 times 3 is 6. Focusing on the fractions, I got 4 minus 3. This will become 1/6. And 8 minus 2 will become 6 and 1/6. And that's pretty much it. Now, let's look at the book if there's any other tricks or tips they give us. A lot of these are just making sure that they have like fractions. There's the method, too, of writing it as an improper fraction. So let's actually touch on this. Because in this one, here we go. Here we go. This is exactly what I was talking about. 2 1/3 minus 1 2/3. So let's show you this. This is why I needed you to understand how to do that second method. So we have 2 1/3 minus 1 2/3. I can't do 1 minus 2. Even though the denominators are the same, I can't say it's negative 1/3. I can't do that. And then do 2 and 1 minus 1 be 1 and negative 1/3. This makes no sense. So I can't do this normally. I'm going to have to convert these in order to do this. So in this case, when you have like fractions and you're taking away or subtracting a bigger chunk than the other, there's two things you can do. One, convert both of these into improper fractions, or two, take what you have here. That is 3/3. Or sorry, yeah, 3 out of 3. You could do it to where this becomes nothing, and now you've got 5/3. Actually, that was backwards. Let me, just ignore me. Just ignore me. It would have been over this way, where this would have become 1, and you'd add 3 more to the top, and it would become 4/3. That's one way you can do it. Because remember, 1 whole here is 3 out of 3 in this case. It's the denominator. But let's not complicate it too much. Let's take this back to the original question, which was 2 1/3 minus 1 2/3. Now, again, walking you through this very carefully, I can take 1 whole, which is 3/3, add these together to make it 4/3, and then just keep the other 1 because that was 2 before. Now I can subtract. 4 minus 2 is 2/3. 1 minus 1 is 0, so my answer would just be 2/3. That's one way you can do that. It's like borrowing. It's like borrowing. So again, this was 1/3. This was 2. I would borrow from here to make this 1, and it would become 3 out of 3 added. My 3 would stay the same in my denominator, but this 3 plus 1 would make this 4. 4 minus 2 is 2. 1 minus 1 is 0, but we don't say 0 2/3, so we just ignore it, and it'll become 2/3. Now, let's rewrite the entire problem and show you the other way to do this. 2 1/3 minus 1 2/3. We're going to convert these into improper fractions. Whole number times denominator plus numerator. 2 times 3 is 6, plus 1 is 7. This will become 7/3 minus 1 times 2. Or sorry, 1 times 3 is 3, plus 2 would be 1 times 3 is 3, plus 2 would become 5. I'm tired. 5/3. Now I can just go ahead and subtract across because they're both improper. 7 minus 5 gives me 2. And my answer is still 2/3, just like it was before. So very important that you guys learn that method, because otherwise, unless you know how to borrow from the whole number and just add, like I showed you, it's not going to work. So either one of these methods is possible. And I want to say that's it. There are examples here. Let's go over some of them just so that we can kind of, put an end to this and also get you some practice. So let's look at the first one. We have 7 minus 1.5. 7 minus 1 and 1/2. Now, I can't do this the way that you would think right off the bat here. So what I'm going to do is I am going to convert that 1 and 1/2 into an improper fraction. 1 times 2 is 2 plus 1 is 3. So this will become 3/2. That 7 is a whole number. That means this means 7/1. Now, in order to make that 1, 2, I'm just going to multiply these both by 2. New equation, 14/2 minus 3/2. 14 minus 3 makes this 11/2. Improper fraction. Therefore, I am dividing. 11 divided by 2. 2 will go into 11 5 times, which will be 10. When I subtract, I will have 5 and 1/2 as my answer. Now, let me do that again, but this time, let's slow-mo that thing. So let's rewrite the question. It was 7 minus 1 and 1/2. I can't subtract 1 and 1/2 from 7 because 1, 7's not a mixed number, and 2, this is a mixed number, so I can't really subtract. Now, some of you can say, well, you can subtract 1 from 7, that'd be 6, minus 1/2, you would know is 5 and 1/2. Cool, that's great. If you want to do that, that's fine. That'll work. But in this case, let's show the mathematical way of doing this. So again, I'm going to turn that 7 into 7/1 because it is a whole number. And that 1.5 will become an improper fraction by whole number, which is 1, times denominator, which is 2. 1 times 2 is 2, plus 1 more is 3. So this will become 3/2. So my 1 and 1/2 became 3/2. My 7 became 7/1. Two fractions. Now I can subtract. Correct? Wrong. I can't, because I have two denominators that are not the same. Therefore, I'm going to make them the same. Easy way to make 1 into 2 is multiply them both by 2. 7 times 2 will become 14. And 1 times 2 will become 2. Now that I have like fractions, I can subtract. My answer is going to have a denominator of 2 because these will stay the same. 14 minus 3 will be 11. I have 11/2. Improper fraction, not simplified. Don't know why my 1 went away. There we go. Therefore, I need to simplify this by doing division. 11 divided by 2. 2 will not go into 1, but 2 will go into 11 5 times, which will become 10. When I subtract, I'll have 1 left over, and my answer is 5 and 1/2. And that's it. Let's do one more example here, and then we will call it a video. Let's take a doozy here. Let's take K. I like K. So, 3 1/4 minus 1 3/4. Now, we have like terms already, but I can't really do 1 minus 3. Not happening. So again, what I could do is take one of these from 3, make this back into 2, but now I'm going to have 4 out of 4 added to this. The 4's will stay the same, but that 4 and 1 will become 5. So that 3 becomes 2, and that 1/4 becomes 5/4, where I can do 5 minus 3 is 2. 2/4. 2 minus 1 is 1, but that 2/4 is not simplified. It's 1 1/2 is my answer. That's one way to do it. Another way to do it is making these into improper fractions. So let me double check 3 1/4. Yes. Now, I'd have to do this. 3 times 4 is 12 plus 1 is 13. So I got 13 over 4 minus 1 times 4 is 4 plus 3 is 7 over 4. This will give me 13 minus 7, take away 3, that'll be 10. I gotta take away 4 more. It will be 6 out of 4. Improper fraction. 4 will go into 6 one time. That will be 4. When I subtract, I have 2 left over. 1 2/4, which is not simplified. That 2/4 needs to be divided by 2, so my answer is 1 1/2. 2 divided by 2 is 1. 4 divided by 2 is 2. So, 2 different ways of solving this one. Again, this is when you're going to have a fraction that you're subtracting that's bigger than the other one. You can't have a negative in here. You're going to either have to borrow from the whole number, or you're going to have to convert into improper fractions and do it the long way. So, as always, any questions, comments, concerns, you guys know where to reach me. I've been Mr. P. This has been a math lesson. You guys have been great. Hopefully you took really good notes. I will catch you guys on the next one.